Thanks for coming, guys. On a Sunday night, especially while CNY is still not over. But yeah, today I know there's a EIP presentation at 9:30, so I'm going to try my very very best to try and like cover this at least most of it as much as I can. Can I just check you guys can see my screen? Like it's clear, you can hear me properly.
Yep, can.
Okay, thank you. Yep. Okay, so oh no, let me go back one more. Yeah, so I think firstly, like I think cause 3D printing or additive manufacturing, it's not the most like easy to understand thing. I'm pretty sure like by now some of us, like when we were kids or like teenagers, we might have heard of when they printed like the first organ, and then we might have like some 3D printers in our schools and stuff. But just like a quick intro, so like what AM is, or additive manufacturing, actually it's additive, right? So it's actually just a fancy name for 3D printing. You could say that additive manufacturing is the bigger umbrella, and it includes a lot of other um technologies as well, and 3D printing is kind of a subset if you want to be very technical. But usually they just use these terms like interchangeably. Yeah, but the idea of additive, right? So it's in contrast to traditional manufacturing, where you kind of have a block of something, right? And then you just like shave, or like you try to cut stuff out of it. So additive manufacturing goes like kind of in the opposite direction. We're just building something layer by layer, so it's additive in that sense. Yeah, and then this infographic, I just think it's a pretty good overview. So you have a few kinds of like materials, so thermoplastics, you have metals, ceramics, and then even like biomaterials, right? And then even within these, they're trying to come up with a lot of ways to create new materials, and like material science is something that's very interlinked with AM. Yeah, and then you also have some applications where it's useful for prototyping, it's useful for manufacturing, it's useful for even, it's kind of divided into two, right? So for your consumers as well as for your industrial applications. Yeah, and then you have some benefits. These things will all go in deeper detail later, but some applications, so like automobiles, like motor vehicles, and then a lot of actually very close to us, like areas that are very close to us, right? So consumer products, or even medical stuff, or aerospace. There's a lot of applications, and then for now these are the percentages. But yeah, so traditional stuff would be like here, so like subtractive, like machining, or you inject some, so in the injection molding, like formative manufacturing is kind of like how you make phone cases, right? So you just inject plastic into a mold, and that's like a really quick way. But yeah, so the idea is just that this manufacturing is so broad, right? And then the reason that this kind of like came about was because manufacturing is there's so many different kinds of things that you can make, and so many demands. So like AM, there'll be a story later, but this is kind of what it is in general. Yeah, and then there's actually a lot of materials that you can like use in AM. So like I think I didn't really know this when I first went in. I think the ones that I've only seen like the plastic ones, or like the very like colorful ones that I think we might be able to see in school. Yeah, but in university I've been able to see a metal one, and then there's actually even like living cell stuff. So like how they make organs and stuff, right? They actually use a lot of those. Yeah,
Sorry, Rebecca, are you recording?
I am, but I'm recording
Oh,
on
okay.
my computer, so
Okay, sure,
yeah,
sure,
it
sure.
might not show
Because I
on
can't
Zoom.
see it from here. Yeah, can.
Okay, no problem. Yeah, so again, like this is also just a breakdown in like of just what a 3D printer might look like. There's a lot of different types, but it's just a comparison, right? So some of us might know from like primary school, or like our own curiosity, how a regular ink printer works, right? So you run a paper to the bottom, and then there's like a drum, and then you feed like ink, right, onto the paper, and it's something like that, right? So you basically like extrude ink from a nozzle. But like how a 3D printer works is that it's very similar, but it kind of changes once you add in the third dimension, right? So in inkjet printing, it's really just I run it one time, one print cycle, and then I have a 2D digital file like that's been printed onto paper. But for 3D printing, it's a lot of like print cycles, right? And then I can use all sorts of materials because I'm actually building something that's like supposed to stand up on its own, rather than just be displayed on a piece of paper. Yeah, so I think that, I hope that's clear. So just like a very like a very simple comparison. Yeah, so a very brief history. Actually, 3D printing has been around for longer than some people know. So I think the earliest they can trace it back to is the late 1970s, early 1980s, where this is quite a funny story. So there's this Japanese lawyer that's supposed to know how to file patents, but unfortunately he like messed up the time, so he wasn't able to get his patent. Yeah, so this was quite embarrassing. But then he is technically the first person that's credited with this rapid prototyping technology, and this was the earliest kind of idea for 3D printing. Yeah, and then we have stuff like SLA. So I think this was the first more mature technology that was sort of evolved from RP. And then so after, sorry, I think this is a little bit of a repeat, but yeah, but basically how it works is, you have a light activated resin, and then you start building it, and then again, so each print cycle adds a new layer, and then you get sort of like a cross-sectional like thing, like a 3D thing. But yeah, so the blunder thing is quite funny. But a few years later, there was a team from France that intended to sort of further develop this stereolithography. But yeah, but at this point in time, there wasn't a lot of business interest. So I think they were unable to like get enough funding or enough support, or at least have enough of a motive to keep going. But yeah, but so then came this guy called Charles Hull, and then he's kind of like the father of like 3D printing. I mean, he sort of like made, I think, the most significant contributions at this point in time. Yeah, and then so he was able to finally submit the first patent for SLA, and then he later founded DTM, which is now acquired by 3D Systems, which is this very big public company that some of you guys might know in the 3D printing space. Yeah, but then so this is the first stage, right? So it's sort of in its infancy from the 1980s to 1999. Yeah, but at this point in time, it was only a little bit popular among some industries because of this like rapid prototyping idea, right? But at this point in time, there was also still a huge gap in like just the general like public imagination of what 3D printing could do. But yeah, so towards the end of the 90s, they managed. So Stratasys is another big public company right now. They were able to file a patent for new technology. I'll go into like some of the technologies. It's not too deep, but it's just for everybody to kind of understand like what each technology like vaguely does. But yeah, so still wasn't mainstream, and then another thing is that the prices, right? So you can kind of see on the right that the average costs of printers have gone down by a lot. And then this is not like the diagram doesn't account for inflation, but if you account for inflation of about 116%, yeah. So back then about 300k for a machine, and then that would be equivalent to about 650k today. So that was definitely not within the price range for most like even like solo rich people, or even like just hobbyists, so like kind of like for any individual to own. Yeah, so that was, the cost was a very big hurdle for mainstream adoption at that time. And then this would be the second phase, right? So like adolescence between I think 2000s to just like 1 decade. But actually during this 1 decade, a lot of stuff happened. So this was the decade that some of us might have heard about surgeons and scientists starting to use body cells and starting to build these like synthetic organs. Yeah, and then at this point in time, I think this is interesting for like any one of you who might have looked at any like technology that's gone through like its infancy stage and like started being kind of mainstream. Like every technology like this, it goes through this patent thing, right? So this is like related to IP. When patents expire, or when stuff becomes public, that usually leads to like this very accelerated development, or speed of development in the technology. And this sort of happened during this decade, where so there were open source projects like this project to get a 3D printer to print another 3D printer. Yeah, and then there was also the FDM patent falling into the public domain in the end, so right around 2009. Yeah, and then this definitely helps more companies kind of have access to that knowledge. And then further, once this happens, the drop of the prices drop, and then the technology just slowly becomes more accessible. Yeah. And then yeah, so there's a lot of new companies popping up as a result, and then there's also a lot of media coverage that, because it's quite exciting, right? When you print organs or when you print a prosthetic limb, it gets into the media and it sort of captures that public imagination more than, comparing it to before. But yeah, so at this point in time, so I think this decade, other than, the you know information becoming more public, I think it was just also littered by a lot of like biomedical advancements, and then that's definitely something that's very like newsworthy as well, right? Yeah, so I think now so from about like the past decade or so, there's been a lot more like of a widespread adoption, right? So like maybe you can see the initial parts is figuring out the technology and trying to like capture enough interest or enough of a perception or understanding of the technology, and then after that is when you start to see the technology branch into different industries and different kind of applications. So you can see like 2010 they managed to print this very cool looking prototype car, and then they started experimenting with building with food, and then they had more advancements in prosthetic jaws, and even like Obama, right, like when he talked about 3D printing in one of his speeches in 2013, it also like managed to like rouse up a lot of interest in it. Yeah, so and then continuing on into like building more machines, and then building bones, and then even to like building a whole house that I actually have a photo later, but I think I didn't put it here because I wanted you guys to look at the car, but it's okay. Yeah, and then here I think I'll just briefly quickly go through some of the technology. This is not super important if you're just trying to understand the business side of the industry first, but I thought I kept reading all these acronyms like popping up, and I kind of I was frustrated myself, so I kind of wanted to like understand what was going on. And it's not that difficult once you look at the diagrams. Yeah, so the first thing is the FDM, right? So that's kind of one of the first things we saw. And then how it works is that it melts this plastic, right? And it just sort of like sprays it onto the platform, and it builds something up like this. Yeah, and then SLA, like I said before, so the hull guy. Yeah, basically this is um also kind of using a laser, like hitting it into a liquid resin, and then when you like cure it enough and then you take it out, you have this like very nice cured solid. And then yeah, so another thing is SLS. So I think this was sort of like another thing where they sort of moved away from liquid and they started using, I think this diagram is pretty good. So basically it has like a like a powder bed, and then you shoot a laser in it, and then you're able to like print this thing out, and then you like dig it out, and then but that's kind of the problem with it, right? So it says here like it's quite expensive, and then you need a lot of post processing to like dust off all the powder and then make sure that the surface is very nice. Yeah, and then number four, I think DD. So basically, this is also something like you shoot a lot of lasers or electrons, and then you deposit the metal or whatever polymer it is into like this shape. Yeah, and then I won't go into too much detail, but I think there's two more. Yeah, and then these things they're sort of similar from each other, like at least from my point of view, and I'm not an engineer, but this is also something like you like are able to like get a solid from a liquid tank. Yeah, and the last thing is okay. The last thing is a little bit more different. The last thing kind of uses this like binding agent, so it's kind of put poorly, it's kind of like they shoot glue at powder, and then they kind of glue it together to form form your solid or form your 3D thing. Yeah, but then as you can see, all these technologies are evolving. They're sort of like related to each other, and they also have their own pros and cons. Yeah, and then so like different companies tend to choose different technologies to focus on, or they tend to like build their own technologies, like proprietary things. But usually I think this should give you enough of an idea to understand what um good things or what advantages or what problems companies might have with their chosen technology. Yeah. And then okay, more onto the numbers and like the business side of things, right? So I think just a quick overview. There's a lot of estimates on the market, and then this is one of the more I think one of the more optimistic ones, more of the more ambitious ones, of about 22% of the CAGR, and then yeah, there's even more ambitions. I think they projected quite far into the future, 2035, of like 350 billion, which is quite a lot compared to now. Yeah. And then yeah, so regionally, right now the most saturated or the most mature market is definitely North America. That's why its growth is not as high. But in the APAC region, there's been a lot of investment in it as well, and it's right for at least for now, it's the outlook is that it's going to have a higher growth rate. And then yeah, so this is basically what the AM value chain tends to look like, right? So you can kind of imagine, like, for this entire process to work, you need the digital file, right? The computer aided design, the CAD, and you need a lot of tools on how to create and design something that can be printed, right? And then you need to know like what materials I should be getting, what form they should be in, and like what is the quality. So that's the material supplies part. And you also need the equipment to build your machine, right? So that comes from like usually separated into, so like those huge ones used in the industry, or the desktop ones that you can actually like see in your schools and stuff. Yeah. And then so like during the manufacturing process, there's also like different companies that focus on different parts, like either companies that focus on helping other companies make prototypes, or if you make like one like very sophisticated part, it's like a one-time thing and not like a recurring order. And there's also a lot of post-processing treatment, right? So when you take stuff out, it's definitely not going to be ready immediately. You're going to have to test it, you're going to have to treat it, you're going to have to make sure that you get it to the desired quality or the desired characteristics. And there's also other services, right? So like security, like how do I protect the process, how do I like maintenance for everything. There's a lot. So basically this is what the value chain tends to look like. And then this is kind of what the ecosystem looks like. So for the different applications, you have the different industries here, and you also have like I said before, so the material, software, application design, they can be different companies, they can be all be done by the same company, but these are the system providers. And then you have different communities and different platforms that are trying to get these services from these different players. Yeah. And then this is also just quite similar, but then you also have like different company names that you can kind of see where they tend to try and zero in into. Yeah. And then these are just some more like different kinds of end use parts, or kind of different applications, like end use industries. Yeah. And then this is also just a further classification. So you have like even by material, right? So your machines, they can be split into different kinds. You can use polymers to like make your like very like plasticky things, or you can do metal, right? Metal is also quite a important part in a lot of industries. And then you have the desktop ones, right, that you can actually put on a table. You have ceramic. And so like I said, it's very linked to material science, and a lot of companies tend to, like, some of them you might see across like different machines. Some of them you might see they're just where they are because they want to specialize. And like on the bottom you can kind of see which companies exactly are providing what kind of softwares, what kind of materials, and then even research institutions on like who's focusing on driving the R&D behind it. Yeah. And then here I also have something that I think I'm gonna breeze through because this is probably easier for y'all to read in your own time. But I put about all of the public companies first in case you want to look at their stocks. But so like I said, Scheidesis and DDD, these are very old, very kind of like time proven 3D, very big 3D printing companies. And then you have also a lot of European, so both of those before are American, but in Europe is also a very big market. So you have like Belgium or Germany, and then also I think, yeah, and then there's more American companies here. And then I think these three are either all metal AM, or I think they're all metal AM. Yeah. But so actually I started looking at this. I don't know if you guys remember this from the letter, but I started looking at this industry in general because of Velo 3D, and because I was looking at ARC, I was looking at like more into the CEO and what kind of positioning. But actually I was quite happy to realize that the industry is much bigger than what Velo 3D does. Velo 3D is very, very specialized in high value stuff. So you might know them for their partnership with SpaceX. So they're literally printing like rocket engines, right? So like that kind of precision. and they're kind of identifying this. It's not to say that it's small, but it's to say that they're trying to overcome a very special problem that they believe is going to have like ripple effects and stuff. But just in case you guys wanted to know why, despite having no engineering knowledge, I decided to look into this industry. It's because of this company, and generally I just had a good feeling about it, and I was curious about it, so it kind of embarked on this journey. But yeah, these three companies are, I think, pure play, so they tend to focus on metal, AM machines, and I know Velo 3D does a full stack thing, but then these three are kind of compared to each other a lot. Yeah, and then these are just some other private companies that don't have a ticker symbol, so you can also take a look at them. But if you're looking for stock, then I think they're just really for reference. Yeah, and then okay, I can't believe I managed to breeze through it. But yeah, this is technically the last slide. But this slide also has a lot of stuff that I kind of want to share about. So like looking forward, right? So this industry, it's sort of huge, right? It's kind of like if you just talked about manufacturing as an industry, like that's too big, right? You have to like zero in on what it's being used for. But the thing about this industry is that it's trying to like it's trying to kind of overcome a lot of the problems, or trying to like fill in a lot of the things that traditional manufacturing cannot do. So either if it's like creating parts or creating materials that are too complex, or you weren't able to get a specific like specification, or you weren't able to get it to a certain like a certain metric, like you weren't able to achieve something that you would previously wanted to design. And that's kind of like the hole that this industry wants to plug in, right? It kind of wants people to be able to create the designs that they've been putting off, that they've been rolling off as impossible. And then there's also so many, like I think a lot of infographics you will be able to see it, and then I put some of them before, but it's about lowering costs, right? And a lot of like activity has been going on in the AM industry, especially during COVID, or like during any big supply chain disruption, because this is when manufacturing and keeping your costs low and trying to like get your supply chains, and like if you have a 3D printer at some end, maybe that means that you don't have to like suffer a whole like supply chain disruption, because you're able to print something on demand, when at your like either port or like anywhere that might not have been achievable if you kind of concentrated your manufacturing in a very traditional way. But yeah, but like moving forward, there's definitely a lot of opportunities. There's so many things to go into, right? If you think about additive manufacturing, it is manufacturing, and manufacturing is everything, right? Everything needs some kind of parts, and needs like any we talked about a lot of industries beforehand, right? So there's a chance to change almost everything that we see, and everything that goes into our factories and goes into our daily products, right? So I think there's a few things that I put in bullet point here. This was based on like I think a survey of a lot of AM companies executives on what their kind of challenges, what their kind of like the next step for them is. And then they raised up a lot of stuff, so like actually it's quite related to like ESG and stuff. But they raised things like for EVs, right? There's whenever you have a new technology, or you want to make a very like a new kind of like car or any kind of thing, you have to like look at if I'm trying to design a like a electric motor, like an electric engine, like how would that like what kind of different materials, or what kind of different parts would I be looking for, and is that achievable with traditional manufacturing? And the answer is usually no, right? So there's a lot of other like higher requirements for the kind of stability, or the kind of parts that you're supposed to be able to make to optimize your electric engines. And that's actually something that's going to be a very big thing for the AM industry. Yeah, there's also a lot of like opportunities, a lot of challenges, a lot of problems waiting to be solved in like renewable energy generation, or the storage of energy, distribution. And like I said before, it's all about how to optimize things, how to reduce cost, how to create parts that are able to better serve energy grids better, help these like energy generation places to kind of speed up this like very pressing need of renewable energy, right? So like ESG again is a very important driver. It's a very urgent thing that the industry is trying to solve, and I think that that's why it's something that a lot of the executives bring up. Yeah, and then just for the industry itself, there's also a lot of problems that it's trying to solve, right? So how do I make sure that I can reliably print a part? How do I make sure that like my parts aren't like just like wonky, or like I don't know what goes on during the black box, like I don't know what goes on during the process. I want to know if this part is really printed as well as it is. I want to know, standardization is also a big thing. How do I make sure that like across all these different kinds of technologies, across all these different companies, how do I make sure that there's a standard that we can really reliably like count on, and kind of regulate safely. And also like how do I make sure that there's customizability even when we're producing at mass scale, reproducibility and speed, stuff like that. So even like just if we're just trying to stay the course and be better, there's a lot of stuff to do, right? Yeah, and then even like sustainability on the other side. So like on another end would be like innovating on material, on like how do we like waste less, right? So that was kind of this idea of AM, where instead of shaving off stuff and like having a lot of waste and just like having a lot of like loose powder or like loose parts away, because all I've been doing is like taking blocks and like shaving from it. Like how do I kind of save on that? How do I reuse those things? How do I like kind of like close that loop of making the manufacturing process more sustainable? And then and also material innovation, right? 3D printing, additive manufacturing, a huge part of it, which I think is really interesting, but I technically do not know about enough about material science to learn too much about, is how do they actually create these whole new alloys and whole new materials with different like specifications and different properties, and how do we make stuff that's going to be better for the environment? How do we switch from certain kinds of materials that are bad for the environment by innovating new materials that are less, have a lower carbon footprint but are able to do just the same thing or even better. So that is actually also a huge part in AM, and it's something that some companies are specifically looking at. Yeah, and then last thing, I think also just I kind of mentioned this before when I talked about like supply chains and stuff, but even like just for like this kind of completely or like kind of quite separate application of your AI logistics and your like how you manage your storage, how you manage your digital warehouses, how do you optimize your production so that you are always able to waste less and print faster, and kind of have minimal impact from supply chain disruptions. And how do you kind of design your logistics and design your production in a way that's able to achieve more localization, able to achieve more of a efficiency, and just build like more resilient supply chains, right? And then this is also something that is going to tie in a lot with stuff like AI, and how even just like all of the different technologies like industrial IoT, stuff like that, right? Like so AM has a lot of ends that it's able to like just meet up with those things, and kind of like to kind of just be a plug into that whole, how just in general how companies are manufacturing and how they think about like saving costs and increasing speed, reliability, efficiency, stuff like that. But yeah, so those are just some things. Like honestly, when I was doing this research, I was kind of overwhelmed by like how big this industry is, and how many things there are. Like even though I think I'll just end with this, but like even though this technology has been around since the 80s, and it's not something that's like a recently like few years, like a truly new technology, but it's moving so quickly. And I think that there are a lot of problems, or at least opportunities hiding within the problems, that are quite urgent. So like what I said about the ESG issues, and a lot of things that we're trying, like kind of forced to look at right now, right? So like how do we like better our supply chains? How do we kind of like cut costs during like a recession, stuff like that, right? Like it's stuff that is very urgent, it's very pressing, and I think that there are some catalysts lying here, and I think that even though, like, especially if you look at North America, a lot of the companies are quite mature, it's quite a saturated market. But I think that if you look how there's so many companies, and there's so many angles and so many different opportunities that you could look into, that overall this is just a quite interesting industry that I think I will continue to look at. So there's so many other things for me to look at, and I think I've just started. But I think moving forward, I'm definitely going to look more into like specific like the huge map earlier, right? I'm definitely going to look more into the specific value chain segments, and some of the key players, and to kind of try and suss out a bit more about what each company is facing, or what kind of technologies it has, and then what kind of strategy they have going forward, and then just to kind of understand better like what are the problems that people at these companies are really facing, and then what are the problems that their clients need, what are the problems that different players in the ecosystem are looking at, and then where opportunity lies. But yeah, there's so many there's so many like different information sources and materials, but yeah, so this is just a very quick overview. I hope that it wasn't too heavy, but yeah, so honestly, if you found any of this interesting, or if you'd like to like talk to me about it, or if you might want to like keep doing research with me, just like send me a message on WeCom. And then like I think for you guys, any of you guys who are like looking into a new industry, or like any like even like traditional like older industries, like just go ahead. Like I think there's always updates, there's always like new things that you can like new trends that you can look into, and like new findings that you can share with everybody. And I think that industry research, or just like having a broader view of things rather than just jumping to like whatever stock shows up on your screener, like I think there's still value in it, and there's a reason why a lot of fundamental investors like to look at like have a kind of a top down approach as well. But yeah, it's definitely worth looking into, and I've learned a lot. And then another good part is that you can do something like this, and you can share it with the club. But yeah, I think that's all I have for you guys. I didn't want to make it too heavy, but I hope that gives you a good overview of at least a good introduction to the industry. And then do you guys have any questions?
No, I don't have any questions.
Oh, okay. Yeah, but like in case you like are still thinking about it, or like if you either just like have some other like points that you want to make, you can also just like let me know. I'll send this into the group so that you can also look over it in your own time. But yeah, if not, then yeah, thanks everyone for coming and for spending your Sunday night with me. And then I'll see you guys around the club.
Yes, Rebecca, thank you. So can I get this presentation in email? Rebecca, is it possible?
Sorry, can you have the presentation?
In email, can you able to send it
I'll
presentation
send
to
it
my?
into the group chat.
Thank you so much. Thank you.
Yeah, no problem. Alright, thank you everybody for your attention.
Thank you so much.
Bye bye.
Bye.